A Russian and an American communication satellite have collided 780 kilometers above Siberia. Reported time that there's been an incident like this. With me is Patrick Granfield, Deputy Comment Editor. Patrick, this is something you're going to be writing about in the paper tomorrow morning. Tell us what happened.
Certainly, anytime you have an event like this, a first for space, it's not a first that we're used to talking about, the first probe to Mars, the first probe to Venus, but really an event that is singular in the history of space exploration. Since 1957, since Sputnik was launched, there have been 6,600 satellites that have been launched. And this is the first time that we've had a collision between two of them. And the problem is that there's a lot of debris from the collision. And already in space, there's some 18,000 pieces of debris that are floating out there and that NASA and that the Russian Space Agency is tracking. But this really adds a lot of smaller pieces of debris that they've really got to keep tabs on in these next weeks and months, because you've got spacecraft and the International Space Station and other things like that who are in the same orbit as well.
So does the debris, excuse my ignorance here, but does the debris keep spinning around the Earth, or is there a danger some of it could come down, or what happens to it?
A lot of the debris in space just sits there really permanently. And for years, a lot of scientists have been warning, well, what are we going to do with this space debris? That it was becoming a growing problem. And now perhaps this incident, since it's on Inside TheNational and it'll be on many other news programs, it'll give enough attention to the fact that we do have this debris that's out there that doesn't biodegrade because you're in outer space. What do we do with it? And is it a growing danger? Is it a growing problem?
And also, I mean, just talk us through the speed, the combined speed of these two satellites hitting each other, which was extraordinary.
Certainly. I don't know if you remember your physics class, Crispin, but I think it's 1/2 mv squared is the equation.
Well, you've lost me already. I failed all my physics exams.
That's why you're a journalist, of course.
So help people like me out. What's that mean in English?
So that means that the mass of the items isn't really all that important. What matters is the velocity. And these things were traveling at several thousand kilometers an hour, which means that the explosion, the impact, just creates an enormous amount of energy, even though these satellites, by the standards of objects that are in space, were relatively small. So yeah, a collision at 3,000 or 4,000 kilometers an hour will create a lot of energy and a lot of debris.
Okay, and how are you approaching this in your leading article in the morning?
I think pundits across the world probably can't resist using this as some sort of metaphor. You know, in the West, if you read newspapers, it says, you know, the sky is falling with the markets, and now things are falling out of the sky. But I really don't think we can take that lesson from this one event. I think we should use it as an example of how much we've really learned from outer space. The environmental imagery, the map making, the global positioning systems. We've really come a long way in 50 years since the Russians launched Sputnik.